In this video, we're going to look at how to add and subtract rational expressions. So before we look at adding and subtracting rational expressions, let's just quickly review how we add and subtract fractions. So let's say we wanted to add 1/3 and 1/4. Remember that in order to add or subtract these, we have to have a common denominator. So we're looking for the least common multiple of 3 and 4. So if we were to count by threes, 3, 6, 9, 12, 15, and count by fours, 4, 8, 12, 16, we see that the first one that they have in common is 12. So we want to make both of these denominators 12 using multiplication. So in order to get 3 to be 12, we need to multiply top and bottom by 4. So this would become 4/12. And then to get this denominator to be 12, we would multiply top and bottom by 3. So that would give us 3/12. Now that we have this common denominator, we're going to go ahead and get a total. We have 4/12 over here, we have 3/12 here, so altogether we have 7/12. So we essentially do the same thing as we do with regular fractions when we're working with rational expressions. So in our first example, we're going to look at 1/x plus 2/3. So this denominator, then the first one, only has an x, but we need them to be the same, so it also needs to have a 3 like the other one. So we're just going to multiply top and bottom by 3. So that gives us 3/3x. Now our other fraction has the 3, but it doesn't have the x, so we're going to multiply top and bottom by x. So that gives us 2x/3x. Now, just like we do with regular fractions, we're going to add the numerators. We're just getting a total, and our denominators stay the same. So we can't add 3 plus 2x. We're going to put it in descending order. So this becomes 2x plus 3, and then our denominator is 3x. Remember, because we have no multiplication here, we cannot cancel out those x's. It just stays 2x plus 3 over 3x. So let's look at another one. Let's look at 5/9x plus 7/6x. Now, they both already have the x, but I need to make the numbers be the same, the coefficients. So I'm looking for the least common multiple of 6 and 9. So if I count by 6's and I count by 9's, the first one they would have in common would be 18. So I need to make this 9x into an 18x. So I'm going to multiply top and bottom by 2. So that gives me 10/18x. Now I need to do the same thing with the other one. I need to make the 6x into an 18x. So I'm going to multiply top and bottom by 3. So that gives me plus 21/18x. Now again, we're just adding the numerators together. Our denominator is going to stay 18x. So this gives us 31/18x. And this is our final answer. In the next one, we're going to have a little more complicated denominators. So let's look at x/3x plus 1 plus 5/3x plus 1. So what you'll notice is that our denominators are already the same. When we have more than one thing in our denominator, again, we have to think about them as if there's parentheses around them. So they're exactly the same, so all I need to do is add the numerators together. So I can't actually add them, so I need to just write them as x plus 5, and then my denominator is going to stay 3x plus 1. Again, I cannot cancel out those x's because I don't have multiplication there. So what if the denominators aren't the same? Let's look at 7 over x plus 2 plus 6 over x minus 1. So again, we need to think about these as if they have parentheses around them. So this first denominator has an x plus 2, but it doesn't have this x minus 1. So I need to multiply top and bottom by that x minus 1. So that will give me 7 times x minus 1 over x plus 2 times x minus 1. And in a minute, I'm going to distribute this 7. Now, my other denominator has the x minus 1, but it doesn't have the x plus 2. So I need to multiply top and bottom by x plus 2. So I'll have 6 times x plus 2 over x plus 2 times x minus 1. So if you're wondering why I'm not canceling out the common terms, like in the first one, the x minus 1s, it's because I just put those in there. So if I canceled them out, I would be right back where I started. So what I'm going to do next is distribute here. So I'll have 7x minus 7 over x plus 2, x minus 1. So we always leave our denominators factored. We're never going to multiply those denominators out. So distributing in the second one, that gives me 6x plus 12 over x plus 2 times x minus 1. So now again, I'm just going to combine the numerators together, and I'm going to leave my denominator as x plus 2 times x minus 1. So I'm going to start by combining the x's. 7x plus 6x is 13x, and negative 7 plus 12 is positive 5. So this is 13x plus 5 over x plus 2 times x minus 1. So let's look at a subtraction problem. So let's say we have 3 over 2y minus 5 over 4. Okay, so looking at the numbers, 2 and 4, I want to find the least common multiple of 2 and 4. So if I counted by 2's and I counted by 4's, the first number they'd have in common is 4. So I know I need to make my denominator, both of the denominators have a 4, and then they also both need this y. This one already has the y, but it doesn't have the 4, so to make that 2 into a 4, I'm going to multiply top and bottom by 2. So that gives me 6 over 4y. Now the second one has the 4, but it doesn't have the y. So I'm going to multiply top and bottom by y. So that gives me 5y over 4y. Now I'm going to combine my numerators. So negative 5y plus 6. Remember, we want the variable to go first, so it's in descending order. And our denominator stays the same. It stays 4y. And again, we leave it like this. We can't cancel out the y's. We're not allowed to do that because we don't have multiplication. Let's look at one with binomial denominators. So let's say we have 3x over x plus 3, and we're going to subtract 2 over x minus 5. So again, we have to think about these denominators as if they have parentheses around them. So this one has the x plus 3, the first one, but it doesn't have the x minus 5, so I need to multiply top and bottom by x minus 5. So that will give me 3x times x minus 5, and again, I'm going to distribute that in just a moment, over x plus 3 times x minus 5. Now the second one has the x minus 5, but it doesn't have the x plus 3. So I'm going to multiply top and bottom by x plus 3. So I'll have minus 2 times x plus 3, I'll distribute that in a moment, over x plus 3 times x minus 5. So now I'm going to take care of the distribution. 3x times x is 3x squared. 3x times negative 5 is negative 15x. This is all over x plus 3 times x minus 5 still. Now in this second one, I'm going to distribute this as a negative 2. So minus 2x and then minus 6 over x plus 3 x minus 5. So now when I go to combine these, again, my denominator stays the same. It stays x plus 3 over x minus 5, and it stays factored. When I go to combine these, there's nothing for me to combine the 3x squared with, so that goes first. Now I have a negative 15x and a negative 2x, so altogether that's negative 17x. And then this is a negative 6, so minus 6. So here is my final answer.